Trey, we can
Okay.
travel back together.
All right, guys, let's get started here.
Okay.
Because
I'm very
the AP exam is next week, I'm gonna cover the last bit of material. This problem set is shorter than it looks because a lot of these questions are really fast, but they take up a lot of space. But while I remember here, just cross out 24, 25, and 26. We're gonna skip those.
What was that? 5, 6.
Everything else is pretty essential. So like we're gonna cover this last bit of stuff. There's actually this, and then there's another problem set. I'll just rip off. There's just this one other thing we gotta cover called L'Hopital's rule, which is really easy, but that's kind of the last thing we gotta cover. So then we'll cover everything that's on the AP exam. I'll have these aren't like due on Friday or anything. Just you can have, especially those of you guys who aren't taking the exam, you can have. I mean, class will be disrupted, so with AP week, so you can have all that class time to finish them up. But
Woohoo!
What day is the comp one?
Is it Wednesday?
Wednesday.
Wait, they're all on Wednesday?
Lit is on Tuesday. Calculus is on Wednesday.
Yeah, the notes credit, you can go to higher level.
I will give you guys a practice test with solutions.
Yeah.
that you can look at. Hopefully by now you know all the calculus. The AP, everything I've been giving you all year is pretty much like it's what you're going to see in the test. The test likes to have their questions tend to be a little bit on the trickier side. Not all of them, but most of them are pretty what? No, they're not like particularly tricky. There's a few here and there that are tricky. For the most part, they're straightforward. But anyway,
How long is the
test.
yeah,
2
It's like
hours.
3 hours.
what the heck?
What do
3.
you mean, what the heck? It's
It's a long test,
an
yeah.
AP test.
It's going to have a calculator section. Well, it's going to have the multiple choice has a calculator section and a non-calculator section. And then just to mess with you, a lot of the questions on the calculator section,
You can do it.
a calculator. Well, not only that, but the calculator is no help whatsoever.
Yeah.
It's like a purely
love
abstract
that.
question. It's like, why'd you put this in the calculator section? But whatever.
I'd like to screw with you.
Huh?
Yes.
Yeah, exactly. Debated.
Yes.
Sometimes
I'll show you on the calculator. Taking like an integral on the calculator is extremely easy. You can probably figure it out on your own. If I didn't tell you, it's just you press the math menu, go over and click the integral button, and then nowadays the calculator gives you a little squiggly, and you just put the numbers in. It's super easy. I'll show it to you in class though. And then so you should be good. Sorry. Ideally, I'd like to be doing this maybe a week or two ago, but it is what it is.
It is what it is. Mime. Classic mime.
Okay, so these are called differential equations. It's a pretty big thing. In university, there's like a whole class called Intro to Differential Equations, and then there's if you go to graduate school, there's more advanced. All I'm saying is you can take a whole class on these things. You can make a whole career out of studying these, really. There's a couple of famous ones out there that if you can solve them, you win $1 million. Not this one though. All right. So this asks a question. Is there a function out there whose derivative is equal to 2x times the function itself? Is that possible? That's the question it's asking.
Probably.
It is probably, it is possible.
Most.
First thing I want to mention is there's other ways to write this. So I could have written it like this. So don't be shocked if you see one that looks like that. It'll say the same thing. So you're assuming when you see this, because of this symbol here, that y is some function of x, right? Like we've been dealing with most of the time. It's not a function of t or anything like that. So there's one little idea we have to discuss, which is, I'll just go over here. So it is true that if I said like, y equals x cubed, it is true that dy over dx is equal to 3x squared. And I could also write that as Because if you think of what this means, it's a slope, it's a ratio. It's a ratio between a tiny change in y and a tiny change in x for this function. And so I could rewrite this like that. Does that make sense?
Aha!
Now, if you want to get super duper duper technical, you're not technically multiplying both sides by dx, but you basically are. So it's one of those things. You guys know my spirit animal, Mr. Actually. It's one of the ones that he loves to come in and go, actually, dx. What, Mr. Actually?
No, continue.
So is everyone comfortable with this?
Yeah.
We're going to use that on this.
Really? I thought you just showed it to us.
Just
for
for
fun.
nobody else, no worries.
Just
Okay,
for
so-
That's not uncommon. No, I'm just kidding.
So here, you
That was a
go,
joke.
you separate it. So the first step, now very shortly, we're going to do both of these steps in one because it's faster. But no one, that doesn't upset anyone, does it?
No.
Now, what would I do? Suppose I had all the y's on one side and all the x's on the other side. All right, well, let me ask you that. Does that upset anyone? No. Fine with that? So what do? It's very simple manipulation, really. We treated dx and dy like they were their own little nougats, okay? And then separated, these are called separable differential equations. We separated the equation in so that the one side was all y's, the other side was all x's. Okay. So now who's got to guess? What do you think I'm going to do now? Not the
Wait,
derivative.
the x integral?
We're going to integrate. You got it. We're going to integrate both sides. Okay. So what does that do? Well, I'm going to go, okay, so the integral. Now this is the part that might confuse you a little
Oh
bit,
my
which is
goodness, because it's dy.
it's dy.
Wow.
So remember, guys, when you integrate, for example, do a simple one like say 2x, this would be x squared plus a constant. You could also make that symbol a y. As long as these are the same symbol here, it's going to be the same result. So crazy, 2 smiley face. The smiley face would be smiley face squared plus a constant.
Yay!
That makes sense, right?
Woohoo!
So don't be scared by that. This is same variable. So what's the derivative of 1 over y then? Natural log of y. Now, although you might go, wait, so don't you have to add a constant when you integrate? So okay, we do it. I'm going to call this C1, constant 1. This guy is going to be x squared plus some other constant, C2. And you can maybe you guys can guess what's going to happen to those C's.
Go away.
Kind of.
Poof.
Well,
Look at you, Prime.
you see that?
Not unreasonable. Yes.
I don't see that.
So, in fact, this might annoy you.
Is it just C1 over C?
What does C represent? It's okay. This is confusing when you first see it, but trust me, it's not.
Oh,
it's
I
not about-
see. I see. It's because it's two constants, so you can just add them together. Because it's like that's going to be like a 2, and that one's going to be a -3, and when you add them together, it's negative. Okay, yep. it's 7.
Yeah, Jesse, that's a good explanation. Just said. So these just represent arbitrary constants. They can represent any number. So what's to stop me from subtracting C1 from C2 and just getting some new constant? Now it's not probably clear right now. Why not just call it C? There's a trick coming soon. That
Coming soon to theater.
anyway, we'll get to it in a second. So I'm gonna save. I know it's very technical. It's like, oh, just call them C's. Well, if you want to be really precise, these represent different constants, and then would be some new constant. So anyway, you'll see I'm saving C for the very last step.
Woohoo!
Okay? The non-subscripted C. So again, now remember, what am I looking for? I'm searching for a function. Right? I'm searching for y. So now I'm gonna solve for y now.
Okay.
So I'm gonna rewrite this as
Y. E equals E to the x squared plus C. Okay, yes.
How do we feel about that? Oh, sorry, C3, my bad. You guys understand?
Yeah.
Now there's one last thing, which is that's an acceptable way of writing it, but what's way more standard is to notice that this is the same as this. Remember how if you multiply e to so the general principle is e to some power times e to some other power is e to the sum of those powers.
Yes.
That rings a bell, right?
Yeah.
Who dat?
So e to the x.
It's just a number, right?
Just a number.
So So the general solution is that, notice there's no more subscript. The general solution is that so again, the question is, what function would have this weird property? Well, some multiple of e to the x squared would have that property. So,
Why do you lose the subscript?
because e to this, remember this represents some arbitrary constant, like say it was 7, say C3 was 7. Well, it's like, okay, I like what Jesse said earlier, which is suppose for a moment that this, for whatever reason, we'll actually get to this later of like, they can give you like initial conditions that will actually let you find out what C is. This question doesn't have initial conditions, so C could be any number, but suppose this was -5 and this was 2. Okay, then I guess C3 was 7, but this number is e to the 7th power, a totally different number. But I saved the nice, simple, the pretty C.
The original.
Remember that email of I never saw pretty best friends? Wasn't that so epic?
Yeah, that was
Ray
my
Griffin?
favorite one, I think.
That's such a good epic. It's such a good Minecraft moment,
Yeah.
dude.
What was
I
your
guess we're
favorite
not
one
best
of
friends,
those?
Abe.
What?
What was your favorite one of those? Paul?
When they didn't see the pretty best friends.
What did you do?
That part when they and then I was like,
I'm
anyway.
popular with that.
so does that make sense? Why they're different?
Yeah,
They're
no,
different
the
C
point
dots.
is that we're both pretty. That's
A lot of times
pretty
we'll
and
say
hot are
Two very different.
They absorb. Like, oh, he absorbed the other constant. Let's do some more examples.
Let us.
Okay. Oh, by the way, you can check your answer on these really easily. Very easy. Yeah. Like watch.
What the hell?
We said that this,
Well, but if I take in the derivative.
yeah, the equation says that the derivative, so the equation says that this has to be true, right? Okay, oh, sorry. Totally made a mistake there. The equation says that this has to be true. So let's do it and see if it's true. What's the derivative of this?
And the x squared is 1.
But why don't we just do that then? Oh, wait, never mind.
I'm just checking the answer.
Yeah, but then yep.
So this is me taking the derivative of my solution, and this is me multiplying my solution by 2x and showing that they're the same thing. Make sense? So that's just like back in, way back in the day when you'd solve this equation, be like, oh, blah, 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 x is 5, and then you'd plug it back in and show that it actually satisfies that equation. That's exactly what we're doing here. Plugging it back into the differential equation to show that it works. Let's do more examples.
Yeah.
Okay.
Every time I heard that.
This is a weird one. This basically says, is there a function out there whose derivative is equal to the reciprocal of its product with x? That's weird. Okay. So let's rearrange it. See how comfortable you are with rearranging it.
Yes, it's y times dy is equal to 1 over x times dx. Maybe I will not.
Do you feel okay about that?
Wait, hold on. Yes.
So he moved over to this side. This dude moved over to this side.
Yes. First order of business.
So integral time. These actually go really quick once you get the hang of them.
Yeah.
What's the integral of y dy?
1/2
1/2 y squared. And since I knew that there was going to be two constants, I'm just going to absorb them as, you know, we know now that only one side really needs a constant. Okay? And in fact, you know, if you think about this, you might go, well, do I even need a subscript? Because I know the two steps that I'm going to do to isolate my y, right? I'm going to double both sides. Actually, it will be helpful because when you double both sides, right, you get see what I did there? I doubled this and I doubled my constant to just get a new constant.
Jahan, really quick, I might have missed this, but why doesn't the left side have a plus C?
Because I knew that, I mean, I could have written this step. I could have been like, and then absorbed them like I did before
Oh,
to
okay.
make a C3. But a lot of times, once you get the idea that both would have a C and then you would just subtract one of the C's from both sides, then you can just usually do this. So most of the time you omit this step.
Okay.
Oh, yes. Okay.
Do we feel okay
Oh
about
my
that?
God, no.
Hell no.
It's gonna take
How many, did you ever read those books?
Of course I did. Everybody did.
Yeah, I read so many of those books.
I never
They
really
kept
got the. I mean, they were.
Okay.
No.
And there you go. Feels pretty good.
Feels pretty good. Yep.
Now you could make
Feelings engaged.
an argument that
Yes.
could you also admit like the negative solution to this? Yeah, but be careful not to say plus or minus, because then if you say y equals plus or minus a thing, what you're describing is not really a function. So you maybe get away with saying that this is a solution, and also this is a solution. But we're not really gonna get too hung up on like, that's kind of nitpicky, but does the algebra all make sense, like the process?
I would say that one's way easier than the first.
Yeah, I would agree with you. There are varying easiness levels. Let's look at, let's just keep going. Let's do a bunch of examples.
Yo.
So there's no problems? No one's confused? What, Griffin?
I'm jiving.
You're jiving?
Yeah,
What is that? Is that like vibing?
Yeah.
but it's a jive.
Oh,
Did you miss me, Mom?
of course.
Dada, what are you currently playing on Darwin? What are you currently playing for Darwin?
Yeah, Griffin, these guys, they just don't get me because I'm like, I'm all Minecraft good, Fortnite bad, and they're
I'm
all,
playing
Finally,
a
three of the block.
myriad
yeah, they
of
just don't
jigs,
understand me.
and I love jigs. They're my favorite.
Especially Aspintope, right, Aspintope?
Yes, yes.
Separate. Separate.
Divorce.
Divorce.
Ave said first order of business, divorce X and Y.
That's pretty easy, right? That first step is
Divorce?
fairly
Yeah.
simple.
I'd say so.
What's this integral? What's this integral? Right?
We're dying.
This guy would be JB. What's wrong?
What?
What's wrong, JB?
I'm just warm. I'm all right.
So what's the answer then? Almost done. Natural log of this weird stuff.
No.
Is that the technical term?
Weird stuff.
Notice some of the weirdness is like the constant is inside the log, right? That's something that we haven't really encountered much of. Usually like, oh, you integrate and the constant's just
Does
at the
that
very
have
end.
a domain then? Like the only be.
It would affect the domain, yeah. I think. Well, this is a weird one where, I mean, I guess if C was 0, then X couldn't be 0. Oh, but if C was negative, then that would have a big effect on what X could be, right?
Yeah.
Like for example, if C was -2, then X would have to be greater than 2 or less than -2. Yeah, C can have a big effect on what it looks like.
Jay Hall, you want to say hi to Lainey?
Of course. Hello, Delaney. 3 words for Delaney. Duh. Lay. Knee.
Yo!
Beautiful.
Bruh.
Wow, beautiful.
Look at D. D asks a question that says, is there any function whose derivative is equal to the reciprocal of that function?
Line.
Ooh, fancy.
Line of line.
A line?
Line of line. You know that's what I call it, lateral knock, right? I don't know. I'm just guessing things at this point.
I don't think it's natural log. It's it's interesting to throw out a possible answer, but it can't be natural log because the derivative of natural log is 1/x. And the reciprocal of natural log would just look like that. So that can't be the case. But I'm glad you threw out an answer because it can be interesting to just kind of look at how do these functions that we've been studying relate to their own derivatives. But anyway, this one, let's just do our technique.
Do y prime.
Well, you start off maybe by doing that. And then you divorce. Put the y over with the dy and the one with the dx. Take the integral. What's this guy gonna be? 1/2
Y squared.
squared.
Woohoo.
And in this case, yep, same thing. I double both sides and then take the square root. And you get oh, it's pretty painless.
Yeah.
Forbidden word. Forbidden word.
What?
Miss Vestal always makes sure that we can't use interesting to describe anything.
Say seven.
Yeah, she told me that, and then not 5 minutes later said, "Oh, that's interesting."
Oh, we color on it.
It was hilarious.
But
Just saying
like,
in your writing.
Wait, hold.
No, just in general when you're
Does
describing
the C
something.
have to be under the roof?
Yeah. Good observation. Yeah. If the C is outside, that's not correct. The constant has to be because
Is it successfully bird's nested?
let me here real quick. I'll show you
Bless you.
the Minecraft theme song.
Before 18.
you know it.
You know, that stuff, any of the Minecraft music is very common.
So for example,
Let's
I can make
try
C.
it.
What this says is C can be any number I pick. So I can pick that for example. And then I could say, okay, well, I know the derivative of this. So the derivative would be, well, it's 1/2 times 2 times 2x plus 7 to the -1/2, which I could rewrite as 1 over the square root of 2x plus 7. And I go, oh, wait a second, that is the same as the reciprocal,
Yo.
Bro.
right? But if I had the C outside, if I try to go square root of 2x plus 7 like that, well, that one has a derivative of just 1 over root 2x, but that's not equal to the reciprocal of the thing I started with. Feel me?
Anyway, J Hall. You
What's
can't
up?
use interesting to describe anything that, say, you have a book that you were describing and you say it's interesting. You're not allowed to say that because that's a vague term that could be used.
Interesting is the only answer I use.
You see, there are just so many other ways that you
Yeah,
can
like you could say
describe
it's
it.
bussin',
Yeah,
Fascinating.
respectfully.
that is a better word. But I also think,
Meebus.com.
I also
It makes you
think
think more.
that interesting is one of the things that conveys the most emotion based on what tone you use it in. Like, oh, it's really interesting, or oh, it's interesting.
Yes, but say you had to do that when you're
Interesting.
Yeah.
writing. You can't convey that kind of tone.
It's like Spanish.
I know, and that is why I like speaking instead of writing.
You should just troll her by do an essay and use like very.
She already
adjective-
gets me
every
on that.
adjective you have the entire paper put very before it. That would really
That
get
would
her.
be so
Unfortunately, I
Talk about
have a
facts
habit
and
of doing that, and then she like nails me
Okay. I'm gonna jump forward a little bit, guys. And, I'm gonna cover a lot of material today.
I hate sign.
So to go over a couple more examples here that I hope will make you not confused.
Are you going to post on the ground?
Okay.
Okay, let's do it.
All right. Don't be scared. Step one,
Separate.
separate.
Divorce. Divorce.
That was easy, right?
As it always is.
Okay. Integrate. Integrate.
3 words.
What's that going to turn into?
Oh.
So
Over.
negative 2.
Yeah, negative 1 over 1.
Right? Because it's y to the -1 divided by -1,
Mhm.
which could then get rewritten like this.
Mhm.
Nothing wrong with going into the margin and just being like, if you still need to do this as an intermediate step, that's totally fine. What?
Why is the virus?
Because he wanted to be buddies with the dy, so I had to move him over here.
It wasn't
So
fair. Ask them.
that makes more sense.
It
Isn't it fair?
I mean, you surely could have had this one say 1 over y squared and then turn 1 over y squared into this. It just depends on how much mental math you're comfortable doing. Right?
Yeah.
Just to clarify, there's
Mental math.
I think you do want to avoid, you guys, especially as you're, going to university and stuff. Like if you're doing a problem like this should really be like one step. It's totally fine to have scratch work, but you wouldn't want to write a bunch of steps. Like for example, your scratch paper might have.
Hey, Mr. What happened to the -2 thing?
This one.
Yeah, isn't it -2y to -1?
Well, I got to increase this by 1.
Yeah, but then you bring down the 2 first.
No,
No.
you increase and then.
Increase then divide.
Well, because that's what we're thinking.
Yes.
So-
Sometimes my brain is like derivative integral. I don't know.
And I'm pretty sure I've taken the derivative of a couple of answers.
Yeah.
Yeah, it makes
I
sense.
may or may not have just left them too.
Oh, I was gonna wear my blue mask today.
So all I'm saying, guys, is
Bummer.
is there anything wrong with doing all these little mini steps? No, of course not. But you want to, start thinking about keeping your work concise. And the higher up you get, the more advanced math you're doing, the more you can, omit
Concise.
in your final product that we're talking about. You can do this on the side. It's totally fine.
Yes.
See, that's the nice thing about it.
Okay, so anyway, what do we got? So integrate this,
Figure it out for you.
and then we integrate this negative cosine, right?
Yes.
Okay with that?
Yeah.
And so I'm trying to solve for y. So maybe, again, how much do we feel comfortable doing mentally? I'm going to multiply both sides by -1 just to, no more tears, that kind of thing. Makes us happier. Of course, now that's c. Absorb. So some constant, I turned it negative. It's just still some constant. Technically, it's not the same constant I had a step ago, but
How does that stay positive?
Well,
Because
it's
C could be
not
negative.
C.
Magic.
Yes, C could be
Technically
whatever.
not.
Aaron, magic.
Plus -4.
I could write -c. Nothing wrong with that. Because yeah, subtracting an arbitrary constant is the same as adding. It's totally fine.
Wait, Paul, if you chose to write -c, would you write -c for which one?
You could, I guess, you could say, oh, it's the same c now.
Okay.
Get wrecked.
Yeah, get wrecked.
That's
So
always weird.
once again, the constant is in kind of a weird place. He's on the bottom of the fraction being added to the cosine. So again, same like I was just talking about a few minutes ago, you can't have the plus c out here. That would just be wrong.
Right.
No.
Red. Bruh.
Can't.
That's a bro. So, I hope that stuff made sense to you.
Yeah. 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 Well, it did. What do you want me to say?
Good, good.
No?
Okay, so then guys, we're going to go over an example or two where there's a initial condition. So if you look at number 7, those questions give you an initial condition. So by the way, I want to put this in more, maybe more familiar terms. Remember back in the day, like you're learning about y equals mx plus b, and it might say, what's the equation of a line whose slope is 3? You'd say, okay, well this, and there'd be some constant in there. And then you go, okay, then what if it passes through the point 0, 10? Okay, well this is a 10 now. That's basically all this is you construct a function that has a certain property, the property being
Plugging in.
it satisfies the differential equation, and then you're given a point or something, and then you go, okay, I can now figure out the c values. So we have to satisfy this, and then also contain the point 0. So let's figure out the answer to this. It's kind of up to you how you want to. In my opinion, this is probably the simplest way to look at it. Keep the -2 over here. You could have sent the -2 to go live with the y. But do you see why this is a little bit easier?
Yeah.
Why am I just on divorce? I just can't.
Okay, so what this guy is, we're going to integrate. This guy is going to be. This guy's going to be. Okay with that?
Yes.
Yeah.
Okay, and then so my function
Bless you.
e to the -2x, or yeah, we go, I know that this can turn into this. By the way, this is some bigly stuff here. Because this original equation says, what function has a growth rate proportional to its own function? And then the answer is an exponential decay or growth function is the answer to that. So that's a big,
Oh, yeah, that makes
that's a big
sense.
idea.
Yeah, right? Because
So-
it's
Wait,
Yeah.
what do we do with the size?
The what?
we're getting
Point
Isn't the sequence?
contains the points.
yeah, we're
We're
getting
getting there.
there.
We're getting there.
Okay.
So then it says this, we're most of the way there, but also this has to satisfy when x is 0, the y value has to be 5. So let's go ahead and plug that in. So what's c?
Trippy.
So my final answer, what they call the particular solution, meaning it's particular to satisfy that, y equals 5e to the -2x. You feel okay about that?
Yeah.
Yeah.
All right. We got time to do one more of those. One more example?
10. I want those negatives.
Sure.
Pretty please.
It has negatives. Scary negatives.
They are. Negative
Scary.
energy is affecting me. See, it's affecting her too.
By the way, last remark here, if you think about this equation described a whole family of exponential decay curves.
Family.
well, sloppy diagram, sorry, but hopefully the idea makes sense. Because depending on your choice of C, it could be any of these. In fact, if C was negative, it would look like this. Right, so the general solution describes this whole family of curves, and then what happens when you say, well, how about if it contains the point 0.5, it pins you down to like a single curve. Now you have one function. Okay, we'll do 10, and we're gonna look at some slope fields.
Schlop.
The slope fields are pretty simple, so it should be a nice cool down.
Cool
So 10
down.
Cool down. 'Cause the brain is overheated, right?
Always.
Okay, so the left side's gonna be y dy. The right side's gonna be negative 2x dx. Do we all agree about that?
Ooh, yeah.
Okay. Integrate both sides. 1/2 y squared is equal to negative x squared plus some constant. No issues there, right?
Yeah.
We can double both sides and take a square root. Oops. Got a symbol. Sorry.
Food.
Do we feel okay about that?
Yep.
And then keep in mind, like I was mentioning earlier, there's sort of like a plus or minus there. This, you got to keep in mind, because it said y squared, y could be negative, right? And still have the same right-hand side. So, so now, because this, now I'm especially mindful of that because it says, well, you got the point -1, -3. So let's do it. When y is -3, x is -1. Make sense?
Yeah.
So what's C? Yeah, and then you have to say, well, I kind of have to put a minus sign there for this to work out. Right, so the answer to C has to be 11. We feel okay about that? So the final answer is that y is negative the square root of 11 minus 2. Sorry, 2x. Sorry, 2x squared. Might be. We're okay with that?
Yep.
Anyone know what shape that is?
Almost straight.
Isn't it a semicircle?
Yeah.
Semicircle? Yeah, I know what I'm talking
Hopefully you
about.
remember this form, like, this is a simpler version, like if I could,
Sometimes I don't.
this would be a semicircle with 4 and -4 as x intercepts. This is an upside down semicircle with,
Some wacky
yeah, the
numbers.
square root of 11 halves would be the 2.
Yeah.
Yeah, when we got to this step, this describes a whole family of semicircles. They could be frownies or smileys. Turned out it was a smiley.
Yay! Happy math.
Happy. All right, guys, look at number 12. We're going to draw a slope field. You might be wondering, what the heck is that?
Is that like
I
a
am
family?
wondering that.
It's a bunch of lines. That's all.
Yeah,
I'm gonna
it's like a
do
little
it on the board
dashes.
because I forgot I forgot
The video.
Complication.
So look at A.
Are we doing 11 or 12?
Oh, sorry, 11. My bad.
Ah,
Sorry.
how dare you lie.
Huh?
The way you
Yeah,
lie.
you just use facts and logic.
I
out
tell you
there.
what
That's
I'm
good.
gonna do. I'm gonna do.
Okay,
Let's
we
see.
probably knock out
One of the
these.
only
These are really
songs
fast
that I
most of the
listen
time. So 11A is like this. It says, I've got a function that satisfies this differential equation. Let's rephrase it. What this says is that on my function, the slope is equal to the x value.
Oh,
So, for example, so there's a bunch of dots on this. 1, 2, 3. 1, 2, 3. I'm going to just freehand mine, but hopefully the dot showed up on yours.
Yeah.
Than this one. So, for example, let's say the point, I don't know, here's the point 2, 1. What would the slope be at the point 2, 1? 2. Just eyeball it. How about at the point 2, 2?
2,
2, and the point 2, 3.
2.
Oh, and then you go like, oh, I guess along any line where the x value is just held constant, the slopes are all just that x value. So you should have a little drawing like that. How about at like 1, 0? 1, and at 1, 1, and at 1, 2, and at 1, 3. You guys see how I'm getting these?
Mhm.
How about at 0, 0? 0, 0, 0, 0, 0, 0, 0. Oh, I forgot the 3. Any spot where the x value is 3, the slope's going to be
Wow,
3.
that is weird looking. I
And
love
then
it.
how about
I
when
dislike
x is
this
negative 1?
greatly.
The slopes are negative 1.
Is there anything in that you do like about it? Yes,
And then
exponential
negative
broken
2. You
decay.
guys see what's going on here?
Good news. I don't think. Yes.
Okay.
Monkey.
I got kind of lazy in the last one, sorry. So here's some thinky winkies for you. What family of functions is this describing? They don't look linear to me.
Yeah, forever.
Oh,
Parabolas.
They
Yeah.
don't look
Because,
linear.
and we'll cover this tomorrow, but you can have this describes a general solution, meaning any solution to this differential equation would have to kind of follow this kind of slope field. So, for example, maybe it looks something like this. It's a rough sketch, but, and by the way, this particular one, this is an easy one. I'll just, here, just because you guys are so great. I'm gonna solve it for you. Wow. How impressed are you? Wow. Okay, if I solve this, look what I get. I get y equals 1/2 x squared plus some constant. Oh,
Oh
There we
my
go.
goodness.
so this slope field describes a whole family of
Oh,
parabolas. It's it's a parabola with a 1/2 factor that's been shifted up or down any amount. And you can see that. That's what the picture is describing.
Whee!
See what I'm talking about?
Yeah,
Okay.
I like that.
How about B is very similar. I'm sure you can figure that one out. C also. C is a boring one. What is C
Yeah.
describing?
It's a square where the slope is 1.
Yeah. No matter what point you're at, the slope is always 1. So you're just gonna have a whole field of 1 slopes.
Amazing.
What?
There's one more.
Amazing.
Amazing.
No, 1 is
What?
like a line. It's like the y is equal to x.
It's the
No,
slope.
it's like this.
It's the slope.
It's
Yeah, that
it's
was,
when y is equal to
I'm
x.
seeing what I was missing there.
Okay. Right.
Caleb, don't prank me today, bro.
It's a little, I apologize.
Goodness.
For my actions.
Okay. The last one we're gonna cover, guys. We have time for this. This is a weird one. This one. I think off the top of my head, you'd have a really hard time solving this one algebraically, like actually trying to solve the differential equation. So let me clarify, you do not have to solve these differential equations, you just have to draw the slope field. So let's just do a couple quick, simple examples. Let's say at the point 1, 2, what kind of slope would we have?
3.
3. How about the point -2, 3?
1.
You feel me? Does that make sense? So at any given point, you could just, an inefficient method is to go around and just randomly pick points, add the x and the y values, and then draw a slope. So, oh, there's the point 1, 2. I'm going to draw a slope of 3. There's the point -2, 3. I'm going to draw a slope of 1. You get the idea? But you can kind of strategize a little bit and be like, along what line will the slopes all be 0?
Y is equal to
When-
negative x.
X and Y.
Y
Yeah.
is equal to negative x.
If the x and y values are opposite, you're gonna have a slope of 0. Do we understand that?
Yeah.
So points like -1, -2, -3. So basically along this line, you're gonna have, I made that line too big, sorry. You're gonna have a whole bunch of flats. It's hard to draw this with the dots, sorry, I'm doing my best here. Dot. So -3 has a flat line, -2 has a flat line, -1 has a flat line. So there's flat lines like this.
Death everywhere.
And then from there, you can kind of systematically go, well, what if I hold, say, a y value constant? Like say when y is 0. Well, if y is 0, then the x value would determine the slope. And so you would just kind of go over this. Anyway, you can finish that one up. You're gonna get kind of a strange looking shape. It's not gonna be like super basic.
Alrighty.
Thanks.